projected body can reach. This number N, number A. Number B, algebraic of the velocity vector when the stone is 78.4 meter height, then find its velocity. The required again, find algebraic of the velocity vector when the stone is a distance 78.4 meters height, then find its velocity. Number C, graph both the position time graph and use them to analyze the motion. Look at, my dear student, the solution. xt equals 49t minus 4.9t squared. This is the relation. Then the velocity with differentiation respect to time t. We have x function in t. What is the velocity? V equals dx over dt. By using derivative respect to time t, then vt equals 49 minus 9.8t. My dear student, when the stone reaches to maximum height, what did you use? X student. V final or final velocity equals 0. Then by substitution from the previous equation, we know that 49 minus 9.8t equals 0, then t equal 5 seconds. Maximum height, when x, to find the maximum height when time equals 5, by using t equals 5, then maximum height became 49 times 5 minus 4.9 times 5 squared equals 122.5 meters. The maximum height when t time equals 5, the stone is 122.5 meter. Number B, when the stone is 78.4 meters high, when x equals 78.4, by substitution about x in the equation, then to find the value of t. Therefore 49t minus 4.9t squared equals 78.4. My dear student, 4.9t squared equals minus 49t plus 78.4 equals 0. Divided each term by 4.9. Then equation became t squared minus 10t plus 16 equals 0. Then by using factorization or calculator to find the value of t, we have t equals 8 and t equals 2. In this distance, the time has two times. The displacement 78.4 when t equals 2 or t equals 8. How? When, my dear student, projected stone up, it reaches 78.4 with 8 seconds. When return the same distance, t became 2 seconds only. My dear student, find the velocity when t equals 2 by substitution about t equals 2, then v equals 29.4 meter per second. What is the velocity when t equals 8? Substitution about t equals 8, then velocity equals 29.4 meter per second. The stone is 78.4 meter once ascending after 2 seconds and once descending after 8 seconds. Algebraic measure of the velocity is 29.4 or negative 29.4. The velocity of the stone in the two cases, norm positive or negative, 29.4 equals 29.4 meter per second. From the position time graph, my dear student, we find that, look at horizontal time but vertical position vector xt. Look at the time 1, 2, 3, 4, 5 to 8 to 9 to 10, and by using the equation we graph the position time of the stone. Look at when t equal 2, the xt equals 78.4. Also, when t equals 6 to reach maximum 117.6. When t equals 8, also xt equals 78.4. My dear student, the stone reaches the maximum height 122.5 when t equals 5 seconds. The stone gets back to the projection point once again when t equals what? Equals 10. When t equals 10, the stone gets back to projection point once. The ascending stage took 5 seconds and return, and descending stage took another 5 seconds. Look at when 5 at t equals 5, the stone is projected up. After the stage another 5 seconds, the stone is down. The stone was 78.4 meter high when t equals 2 or t equals 8. Then if we study the position time graph, we find the relation between t and xt. From the velocity time graph, we find that, my dear student, the velocity time graph, this is velocity time graph, time from 1 to 10, velocity to 49. Look at, my dear student, we have velocity up and down. This is the graph of velocity time graph. Look at this point. Clear that when find or when draw the velocity time graph with straight line, but the first position time graph is curve. Remember, my dear student, the velocity is derivative of x, or v equals d over dt of displacement or distance. The starting initial velocity of the stone was 49 meter per second, and it gets to decreases during the time interval closed 0,5 interval until the stone got instantaneously static when t equals 5, when the stone reaches its maximum height. Then the velocity increases in the maximum height equals what? Area of triangle OAL by using half base times height, half times 5 times 49 equals 122.5 meter. Then acceleration, my dear student, dv express the change of the velocity vector during the time delta t. Acceleration, average acceleration, a vector given by relation a average delta v over delta t. What you mean delta v, my dear student? Change of the velocity. Delta t, change of the time, or limit when delta t tends to 0, v multiply t plus delta d minus vt over delta t. This is definition of differentiation. dv over dt by using limit delta t tends to 0, f of t plus delta t minus f of t over delta t. Average equal dv over dt is the rate of a change of the velocity vector with respect to time t. The slope of the tangent to the velocity time graph. V, we know that v equals dx over dt. V vector equals dx over dt, or the velocity change of displacement respect to time. Acceleration also dv over dt, or second derivative of x respect to time t. Now, my dear student, we are translate to another example. Integration from 1 to 4 x squared plus 2x minus 1 dx equals x power 3 over 3 plus 2x squared over 2 minus x. From 1 to 4, substitution from 1 to 4, my dear student, then answer is, my dear student, 33. Reduce the velocity and displacement. Acceleration, f acceleration dv over dt. Then, my dear student, integration a dt equals integration of dv. We know that, my dear student, acceleration equal dv over dt. Therefore, velocity equal integration of a respect to time t. We know that integration v naught from v naught to v dv equals integration a from 0 to t respect to time t. Then v minus v naught equals integration from 0 to t a respect to time t, equal area under acceleration time graph. Then if the acceleration a is constant, then v minus v naught equals a integration dt from 0 to t equals what? We deduce that the first equation, v equal v naught plus at. Example. Particles start to move in a straight line from the origin point with initial velocity of magnitude 8 meter per second, and the acceleration of motion after t second is given by the relation 3t minus 2. Remember, my dear student, acceleration of motion after t second is given by relation 3t minus 2. What is the required? Find each the velocity particle and its displacement after 2 seconds from the starting of motion. What is the required again? Find each of the velocity of particle and its displacement after 2 seconds from the starting of motion. My dear student, we know that the acceleration is differentiation of the velocity respect to time, and the velocity is a change of displacement respect to time. But in this example, we know that if we have acceleration and the required is the velocity, what do we use? Excellent student, we use integration. Why? Because v is integration acceleration respect to time. If the required is displacement, we use also integration. Why? Because x is integration of the velocity respect to time t. My dear student, in this example we have relation of a respect to time t. At the first, we know that the required velocity, by using integration acceleration respect to time t to find the value of the velocity. My dear student, look at the solution. Acceleration equal 3t minus 2. By using integration, find the value of the velocity. What is the integration 3t minus 2? Then 3t squared over 2 minus 2t plus c. What is the c? My dear student, constant acceleration. V naught in this case equal 8 when t equals 0 by using to find the value of c. C is equals 8. Then we write equation again, velocity equal 3 over 2 t squared minus 2t plus 8. 8 replace with c. Then after 2, v2 equals, by substitution about t equals 2, 3 over 2 times 4 minus 2 times 2 plus 8. Then the velocity is 10 meter per second. Since, my dear student, the relation between velocity and time 3 over 2, v equals 3 over 2t squared minus 2t plus 8, then by using integration to find acceleration, to find displacement x, by using integration 3 over 2t squared minus 2t plus 8 dt, then x equals half t power 3 minus 2 minus t squared plus 8t plus t dash. Then to find the value of c dash, x equals 0 when t equals 0, we deduce that c dash equals 0, constant of integration. Then we write the equation again, x equals half t power 3 minus t squared plus 8t. Then, my dear student, we substitution about t equals 2, then s equals 16 meter. Another example. Particle moves in a straight line that algebraic of its velocity is given as a function of time by the relation v equals 6t squared minus 24, where v is measured in particle reaches 72 meters per second. Find magnitude of acceleration of the particle where its velocity reaches 30 meters per second, and the magnitude of displacement of particle during t belongs to closed interval 1,4. Solution. My dear student, the relation is v equals 6t squared minus 24. When the velocity of particle reaches 72 meters, then by substitution about v equal 72 to find the value of t. 6t squared equal 96, t squared equal 16, then t equal positive or negative 4. Negative 4 is refused, t equal 4. When the velocity of particle reaches 30 meters per second, by substitution about 30 meters per second, its velocity, then 6t squared minus 24 equals 32 equals 30, then 6t squared equals 54. Divided each term by 6, then t squared equals 9, t equals 3. Then the time equals 3. My dear student, we know that acceleration equals differentiation of velocity respect to time t. Then acceleration equals 12t. My dear student, A by substitution t equals 3 equals 36 meter per second square. Also, my dear student, displacement, we find integration from 1 to 4, interval closed, 1 to 4, velocity respect to 2 time t. Then, my dear student, we know that acceleration, displacement s equals 8, integration from 1 to 4, we replace velocity by relation 6t squared minus 24. Then, my dear student, 2t power 3 minus 24t from 1 to 4, then displacement equals 54 meter. My dear student, we know that if we have acceleration and the required the velocity is integration of acceleration respect to time t. If we have acceleration equals 6t minus 2, what is the integration? 6t power 2 over 2 minus 2t plus c. My dear student, c as constant of integration. Then by using v naught equals 0 and t equals 0 to find the value of constant integration. After that, substitution in equation to find the value of the velocity. Also, my dear student, if we have velocity function in t, the required displacement from closed interval 1 to 4, then, my dear student, we use integration of velocity respect to time t. Why? Because, my dear student, x equal integration of s respect to time t. We know that integration is opposite of differentiation. When we find displacement by using the velocity, we use integration. But when we find velocity with acceleration, we use differentiation. In this example, my dear student, we have velocity. The required is displacement. Then we deduce the displacement by using integration. My dear student, look at again the solution of this example. My dear student, we have acceleration dv over dt. What is the dv over dt? What is the acceleration? It's the equation a equal 12t. By using t equal 3, then find the value of acceleration equals 36 meter per second. My dear student, the third required s equals integration of from 1 to 4 v dt. Then, my dear student, what is the velocity? This velocity, my dear student, equals relation 6t squared minus 24 dt. Then, what is the integration of the relation? X and student, 6t power 3 over 3 minus 24t plus c. My dear student, constant integration is 0 in this case. Why? Because we have different integration 1 to 4. Displacement, my dear student, s equals integration from 1 to 4, 6t squared minus 24 equals 2t power 3 minus 24t. After that, my dear student, by substitution about t equals 4 minus about t equals 1 to find the displacement. Then, my dear student, answer is 54 meter. We deduce that if we have velocity and the required displacement, we use integration. Integration from 1 to 4. What is the velocity? This relation between 6t squared minus 24 is baked to 2 times t. What is the integration? Excellent student. 6t power 3 over 3 or 2t power 3 minus 24t. We have not constant of integration. Why? Because this is definite integration. C equals 0. Then after substitution about t equals 4, then about t equals 1, we subtract the first minus second. Answer is 54 meter. This is displacement S. My dear student, by the end of the lesson, we know that we have acceleration, velocity, displacement, 3 unknown variables. 3 unknown variables, we join 3 unknown variables by equation of motion. The first v equal v naught plus at. Second equation s equals v naught t plus half at square. Third equation v naught v square equal v naught square plus 2as. My dear student, we have 3 variables. We use integration and differentiation to find 2 unknown with one of them is given. As example, if we have acceleration, the required velocity and displacement, what we use? Yes, excellent student, we use integration. Why? Because the given is acceleration. Find the velocity by using integration, acceleration respect to time t. After that, we use integration of the velocity to find acceleration, displacement respect to time t. If the given is displacement, when we use differentiation. Differentiation of displacement respect to time t is the velocity. After that, we use differentiation of the velocity to find the value of acceleration. Unit 1 of dynamic, very important lesson, differentiation of unknown acceleration or velocity or acceleration or displacement, and integration of velocity and acceleration. This very important unit, my dear student. I am very too happy to spend such time with you. Thank you.